Welcome to the UGC lecture series in computer science. In this series of lectures, we have been looking at a subject, software engineering. During session 1, I have been discussing about the importance of software engineering, where I have talked about cost, schedule, and then the quality of the software that need to be built. So in this particular session, we will be looking at that in detail. So most of the discussions for today's session will be doing it on the definitions and notations of software engineering. First, let us talk about the level of technology that we have in today's world. Modern programming practices include use of systematic analysis and design techniques, appropriate notations, structured coding, systematic techniques for examining design documents and source code, and systematic testing. To better understand, as I have told you in the previous session, software engineering is to majorly concentrate on analysis, design, coding and testing. And to develop this level of technology, we have been working on the systematic analysis and design techniques, appropriate notation, structured coding, systematic techniques for examining design documents and source code, and systematic testing. First, we will take an example of a problem. You are given a problem for which you have to build a software system that most students feel will be approximately 10,000 lines of code. Say whatever might be the programming language, you are supposed to build 10,000 lines of code, and if you are working full time on the same program, just highlight how much time it will take to build the system. So the answer generally will be 1 to 3 months of a time to build 10,000 lines of code. And given the same to an expert in programming, there is a good chance that they will be able to build the software and demo it to whoever it might be within 2 months. With 2 months as the completion time, the productivity of the same person who has done the code will be 5,000 lines of code per person month. Generally, we will assess the entire document in terms of lines of code, and these lines of code tomorrow in terms of the effort we will estimate in terms of person months. After having developed such a very good software, the term good software need to be better understood. So whenever we say good software, we look at the reliability of the software. So every software product must possess a basic level of reliability. However, reliability is gained only with great care while pursuing our analysis, design, implementation and system testing along with its maintenance of the same software product. Now let us understand an alternative scenario. We act as clients and pose the same problem to the company. That is, in the business of developing software for any specific clients, though there is no standard productivity figure and it varies a lot, it is fair to say a productivity figure of 1000 lines of code per person month is quite respectable. So anything that we say 1000 lines of code is most respectable per person month. With this productivity, a team of software professionals in a software organization will take 10 person months to build this software system. Now try to understand with the scenario which I have discussed earlier, where a person who was working with this software system able to develop 10,000 lines of code and the current scenario. Now let us try to understand why this difference in productivity between these two scenarios, and why is it that the same student who can produce a software at a productivity of few thousand lines of code per month, while the same person who has been developing a software at the college level, producing only 1000 lines of code per month when working in a company. So the answer of course is that two different things are being built in two different scenarios. In the first scenario, as a student, if you are being built, which is primarily meant for demonstration purposes and is not expected to be used later. So any project that you are developing as a student initially, it will be only for demonstration purposes and you will not be using it at later stages. Because it is not used, nothing of significance depends on the software, and the presence of bugs, lack of quality is not a major concern for you. Neither are the other quality issues like usability, maintainability, portability and etc. we will not bother majorly. So since this is a demonstrated version of a product and it is not to be used in future, we will never look at how exactly we can fix the bug and we will not look at the reliability factor also. On the other hand, an industrial sense software built to solve problem of a client and is used by the client's organization for operating some part of the business, and a malfunction of such a system can have huge impact in terms of financial or business loss. So comparing between two different scenarios that we have been operating with, the first scenario, any software that has been built only for the purpose of demonstration and a software that is made usable by any specific client, we have a large difference between these two products. In the first kind of a scenario, we will not look at the usability of the software, the maintainability of the software, the reusability of the software, whereas in the second case, we look at each and everything because we wanted to have, we did not want to have a major financial loss as a factor. So this needs for higher quality and to satisfy the end users has a major impact on the way software is developed and its cost. So now let us try to understand the problem of why the difference between these two scenarios. So there is a failure to understand the true nature of the problem to be solved is a common and a difficult issue. Hence it requires a careful planning, customer interviews, task observation, prototyping, a preliminary version of user's manual and precise product specification, which can increase both the customer and developer understanding of the problem to be solved. So any which cases, if we wanted to have a better software, as I have already suggested with, an engineering approach towards the software need to be given precise concentration. So anything that has gone through the phase of a careful planning, interviews with the client whom they want to use the system with, task observation, prototyping, preliminary version of user manual and precise product specification will go with a greater version of a quality software. The other point would be on the time factor. Determining optimum staffing levels and proper elapsed times for various activities in software product development is an important and difficult aspect of cost and resource estimation. We may have to place appropriate staff members who are typically involved into the development of software, who will be actively participating because every line of code that we do requires staffing. So as we have undergone a study of effort where it is basically dependent on person months, every line of code is correspondingly mapped towards those person months. So what are the skills required by a person towards the development of these programming aspects or a coding aspect? Basically, between the client and the developer, there needs to be having a communication skill. Then after having communicated the logic of the programming or the logic of the entire concept need to be easily understood. So, the client must have, the developer must have a problem solving skills, and he should also possess a detective skills, that is a backward approach. And it is not necessary that every software engineer possess all the requisite skills, but these skills must be present among the members of the programming team. It is not mandatory that all the three skills are required for the entire programming team, but then as a team leader or a project manager, it is mandatory to possess all these three skills. But as and when the developer used to expertise himself into the project development, he has to undergo a competency in all these three skills. Looking after the infrastructure, facilities and resources, most programmers receive their motivations, reward from the nature of work and are thus quite sensitive and easily frustrated by poor facilities and inadequate resources. Many a times we would have looked at people who work rather in an outside environment and was not given with proper infrastructure. They might feel unhappy to work with the environment that has been provided with them. So, it is more appropriate for the programmers who are rewarded the best and who are given with appropriate facility and resources to work for a better programming. The other aspect that we might be looking at is the training aspect. Most programmers have been trained as computer scientists, electrical engineers, accountants or mathematicians, and purely not as software engineers. As I have been stressing on, software engineers need to effectively understand on the planning skills, design skills, programming skills and the testing skills, and sometimes they have to maintain the entire source code that has been given for them. If they have undergone all these 4 or 5 stages, then they are supposed to have cleared the engineering phase. But then if a person who is about to develop a software is possessing only one skill on the programming, then it may not be effective. So, this has resulted in the entry level programmers who are poorly prepared to become a software engineer. So, any specific concept that has been given to them, they will be able to just code, but they will not understand the logic behind why the client requires such a program to have been developed. The other aspect that we might look at is the management skills. Many of the problems in software project management are unique. Even managers experienced in management of computer hardware projects find software project management to be difficult due to the differences in design methods, notations that were used, development tools and the issues of concern. Whenever we look at the management skills of any specific person, it is not generally with the hardware, it is more appropriate towards software also. A person who has timed or planned for completion of a specific module need to complete it on time. If say a project need to be completed in 32 weeks and every module is appropriately positioned at a week's time, then every week he is supposed to complete that particular task so as to complete that in 32 weeks. So, this seems to be difficult, and the appropriate notations that this particular developer who has used the programming and development tools are to be given highest concentration. The next part is to discuss about the appropriate goals. So, the primary goal of software engineering is development of software products that are appropriate for their internal use. Ideally, every software product should provide optimal levels of generality, efficiency and reliability. So, any specific software that we wish to develop need to be generalized first of all. We may have to understand each and every part of the programming or the concept behind how it is to be developed. Say, if a person is about to travel from one place to another, from the source to destination, what are the intermediary stages where the bus or any other transport will stop? So, this is for an application, and people might quite able to understand what are the different stages at different places where this transport media will stop, and they will also be very happy to know that where is the exact time given for them to have their breakfast or lunch or dinner. So, if it is appropriately being planned over a web page, it will be more clear that this kind of a bus is more preferred rather than any other type of a bus. Now, we will try to understand, as I have already told you, we will try to understand the cost, schedule and time relating to any software project that need to be developed. Though the need for high quality distinguishes industrial strength, software from others, cost and schedule are other major driving forces for development of such software. In the industrial strength software domain, there are three basic forces at play: cost, schedule and quality. The software should be produced at reasonable cost, in a reasonable time and should be of a very good quality. So, this is the basic definition which I have told you when I was explaining about Shah's definition in software engineering. So, these three parameters often drive and define major software projects. Industrial strength software is very expensive primarily due to the fact that software development is extremely labor intensive. So, to get an idea of the costs involved, let us consider the current state of practice in the industry. Lines of code or 1000 lines of code, which is represented as KLOC, kilo lines of code, delivered is by far the most commonly used measure of software size in the industry. As the main cost of producing software is the manpower employed, the cost of developing software is generally measured in terms of person months of effort spent in the development, and productivity is frequently measured in the industry in terms of LOC per person month. Talking about the schedule, schedule is another important factor in many projects. Business trends are dictating that the time to market a product should be reduced. That is, the cycle time from the concept to delivery should be very small. For software, this means it needs to be developed faster and within the specified time. Besides this, there is another factor which is called cost, which gets involved. So, the other major factor driving software engineering is quality. Today, quality is one of the main mantras and business strategies are designed around it. Unfortunately, a large number of instances have occurred regarding the unreliability of the software. The software often does not do what it is supposed to do or does something what it is not supposed to do. Clearly, developing high quality software is another fundamental goal of software engineering. However, while cost is generally well understood, the concept of quality in the context of software further needs a lot of discussion. So, with this rising expectations, we will try to understand two interrelated aspects of these expectations. One is the concern for how much functionality, reliability and performance the software can be provided by a given amount of development effort. The other concern is on the issue of fundamental limitations of software technology. So each report of success in software engineering exerts increased pressure for even higher quality and greater productivity. So to meet the requirements of the software industry, we look at cost, schedule, higher quality and greater productivity of the product. To discuss about the effort that has been given across the different phases of software engineering, we have distributed them as a percentage towards relative effort. Now let us look at this chart where on the x-axis we have provided the different phases of the software development, analysis and design, implementation, testing, adaptation, enhancing and fixing the bugs. During this phase of development, 16% of the project is given due effort towards relative effort and 8% is given towards implementation. 16% of the concentration is given towards testing, 12% towards adapting and 36% towards enhancing, because at the initial level of discussions people may not be aware of what is being developed. So the clients might ask you to enhance the software, which might take 36%, and fixing up all the bugs and making it work and maintain requires 12% of its effort. So if you try to understand from this figure, only 8% of the time overall effort is being given towards implementation, whereas the other independent activities takes the major concentration. Assume having taken up a project, more than 16% of the time will be spending towards analysis and design alone. 16% of the equal quantum of time along with analysis and design will be spending it towards testing. 12% will be spending it towards adaptation. 36% will be spending it towards enhancing the same software. Now let us look at simple project size categories. This is how we define the projects. For a simple trivial project, the number of programmers required is basically 1. The duration for the project may go to a maximum of 4 weeks and the project size might be only 500 lines of code. Whereas the same when considered in terms of a smaller projects, again the same one programmer with 1 to 6 months of time might go with maximum of 2000 lines of code. Whereas a medium project that is to be developed which requires 2 to 5 programmers, which might go beyond 2 years, might go up to 50,000 lines of code. I can give you simple examples where exactly these applications would fit in. Say for example, if I am asking you to develop a compiler, the compiler might take 50,000, minimum 50,000 lines of code, 10,000 to 50,000 lines of code. So the effort which we would require to provide for this kind of a system will be very medium. So we might need 2 to 5 programmers who works between 1 to 2 years might do a compiler. Whereas simple applications of a grocery store information or a simple day-to-day applications which can be developed are the typical examples of a trivial and small scale categories. Whereas industry takes up very large projects which work for 4 to 5 years or 5 to 10 years of gap, will write 1 million lines of code or between 1 million and 10 million lines of code. So for that they might require 100 to 1000 programmers or 2000 to 5000 programmers who are to be managed. Now we will look at the characteristics of the software quality that we have mentioned. If at all we need to bring about a very good quality software, we need all these 6 characteristics that are to be maintained. Characteristic 1 is the functionality, reliability, usability, efficiency, maintainability and portability. Now let's try to define what these T's relating to quality would mean. To define about functionality, the capability to provide functions which meet stated and implied needs when the software is being used. Whereas reliability is defined as the capability to provide failure-free services. So as we were discussing about reliability some time before, lack of reliability means we fail in a lot of versions of a software, and again in the previous slide we have discussed about the distribution of effort where 12% of the time we might fix towards the failures. Usability is defined as the capability to understand, learn and it to be used. Efficiency is defined as the capability to provide appropriate performance relative to the amount of resources being used. Maintainability is defined as the capability to be modified for purposes of making corrections, improvements and adaptation. Many a times most of our clients might ask us a question, is this software maintainable? In such cases we may have to give them promises and allocate certain budget for the same towards maintenance. Portability is defined as the capability to be adapted for different specified environments without applying actions or means other than those for this purpose in the product. So with all these multiple dimensions towards quality, different projects may emphasize different attributes, and a global single number of quality is not possible. However, despite the fact that there are many different quality attributes, reliability is generally accepted to be the main quality criteria. As unreliability of software is due to the presence of defects in the software, one measure of quality is the number of defects in the software delivered per unit size. With this as the majority of quality criterion, the quality objective is to reduce the number of defects per kilo lines of code as much as possible. Current best practices in software engineering have been able to reduce the defect density to less than 1 defect per kilo lines of code. And at this juncture, I request the students to look at the principle of Six Sigma, because Six Sigma looks after defect minimizing the number of defects available. And there are certain more important factors, quality factors that is required towards the productivity of software, which are individual ability, team communication, product complexity, appropriate notations, systematic approaches, change control, level of technology, required reliability, availability, problem understanding, appropriate skills required, facilities and resources, adequacy of training, management skills, appropriate goals and the rising expectations. So some of these that we have looked at in the beginning, which are towards management principles, and when looking at the individual's ability, productivity and quality are the direct functions of individual ability and effort. Two aspects of ability: general competence of the individual, familiarity of the individual with the particular application area. Where there is a lack of familiarity with the application area can result in low productivity and poor quality. And they need to have an appropriate communication between team members. So it is possible for programmers to misunderstand the role of their modules in an evolving system. Design reviews, structured walkthroughs and code reading exercises have the goals of making software more visible and improving communication among programmers. Product complexity, where the complexity of most of the programs will not be on the applicative field. It is not towards application programs, it will be majorly on the utility and system level programs. So a due concentration to be given towards utility and system level programs, if at all we are developing a software that is to be very appropriate and of good quality. So there are appropriate notations that to be used. So good notations can clarify the relationships and interactions of interest, while poor notations complicate and interfere with good practices. So some of the system approaches towards this software engineering include the existence of standard practices is one of the distinguishing characteristic of a professional discipline. It is unreasonable to expect that a single approach towards software development and maintenance will be ever adequate to cover all situations. And at times we may have to look at the change control of the system also. So software must compensate for design deficiencies in the hardware and software tailored to satisfy differing requirements of different customers. So there might be different customers who might require different change of the process. So we might need to satisfy all of their needs basically, so that we understand the requirements completely and start with the design of the work. So the devastating effects of constantly changing requirements can be minimized by applying for change and by formalizing the mechanism of change. Thank you.